Section 2.5, Multiplying Fractions. Many people say that the easiest operation with fractions is multiplication. So let's look at that first. Let's look at multiplying the two fractions 2/3 and 4/5. You can see that I have a picture here, and I have a rectangle. I've divided it up into 3 equal pieces. And what I'm going to do is I'm going to shade in 2/3 of those pieces. So I am showing 2/3 of that rectangle. Well, I only want 4/5 of what I've shaded in. So now what I'm going to do is I'm going to divide this as best as I can into 5 equal pieces going across the other way. And you can see that I have now divided it with the red lines into 5 equal pieces. And I'm going to go through and I'm going to shade in 4/5 of that rectangle. So I shade that in, and the question is, how much is shaded in both blue and red? Well, there are a total of 15 equal pieces in that rectangle because it's a 5 by 3 rectangle. And I'm going to shade this in green, 1, 2, 3, 4, 5, 6, 7, 8 out of those 15 pieces shaded in both the blue and the red. That shows me that 2/3 times 4/5 is equal to 8 out of 15, or 8/15. Notice, if I just go through and multiply straight across, 2 times 4 gives me my 8, 3 times 5 gives me my 15. So, multiplying a fraction by a fraction is really easy. Just go through and multiply the numerators, and then go through and multiply the denominators. You just need to make sure that your final answer is in lowest terms. And in this case, 8/15 is in lowest terms. Let's do another one, this time without pictures. 5/7 times 3/4. I'm just going to go straight across and multiply my numerators and then multiply my denominators. 5 times 3 gives me 15. 7 times 4 gives me 28. Is 15/28 in lowest terms? Remember, the way to check is to see, well, are there any common factors of 15 and 28 other than 1? If you go through that process, you'll see that there are not. The only factors of 15 are 1 times 15 and 3 times 5. The factors of 28 are 1 times 28, 2 times 14, and 4 times 7. The only common factor of both 15 and 28 is 1, so I know that 15/28 is already in lowest terms. Let's look at another one. How about 2/5 times 3/4? I'm going to go through the same process. I'm going to multiply the numerators. 2 times 3 gives me 6. 5 times 4 gives me 20. I take a look at 6/20 and I see that both of those are even numbers. So I know that I can divide both of those by 2/2. 6 divided by 2 gives me 3. 20 divided by 2 gives me 10. 3/10 is in lowest terms because the only common factor of 3 and 10 is 1. So I have that already in lowest terms. But let's look at the same problem again, but look at it a little bit different way. I have 2/5 times 3/4. So, as I said, what we did is we multiplied the numerators 2 times 3 with the denominators 5 times 4 to get our answer. One thing to notice is that the factors in the numerator, 2 times 3, and the factors in the denominator, 5 times 4, the 2 and the 4 are factors that can be reduced themselves. So when I have 2/4, I could say to myself, well, 2/4 is exactly the same thing as 1/2. So I could change that to 1/2. And then I could multiply straight across. 1 times 3 is equal to 3. 5 times 2 gives me 10. Notice I get the same answer either way. This process of changing this and canceling is actually what you are doing. It's called canceling the factors. Sometimes makes things a little bit easier. Here's an example of one that would definitely be easier if you do some canceling first. But first of all, let's just do it by multiplying straight across. If I multiply straight across, 7 times 5 gives me 35, and 21 times 8 gives me 168. Well, 35 over 168 is a pretty large fraction as far as the numbers in the fraction go. And you would have to figure out whether or not you could put that in lower terms or not. If we do it the way that I just talked about, 7/8 times 5/21, I take a look at the 7 and the 21, and I notice that 7 and 21 have a common factor of 7. So what I'm going to do is I'm going to divide both the 7 and the 21 by 7. If I divide 7 by 7, I get 1. If I divide 21 by 7, I get 3. Now I can go through and I can multiply across. 1 times 5 gives me 5. 8 times 3 gives me 24. Now it's already in lowest terms. 5/24 is the lowest term fraction of 35 over 168. And it would probably be kind of hard to figure out 35 over 168 in lowest terms, but they do have a common factor of 7. 35 divided by 7 gives me 5. 168 divided by 7 gives me 24. But to know that might be more difficult, but doing it this particular way makes things a little bit easier. Let's do another one that same way. I have 5/8 times 11/25. As I take a look at the numerator 5 and the denominator 25, I know that I can divide both of those by 5. So 5 divided by 5 is 1, 25 divided by 5 is 5. Now I can go straight across and multiply. 1 times 11 is 11, 8 times 5 is 40. 11/40 is in lowest terms. Remember, I could have, if I had wanted to, here's the original problem again, I could have just gone straight across and multiplied. 5 times 11 is 55. 8 times 25 is 200. But then I would have to put that 55 over 200 in lowest terms. In order to do that, I would have had to divide by that 5 over 5. Which then would give me that 11/40 for an answer. But it's probably easier to go through and do the division by 5 first, if that is possible. One other thing to point out. Here's another example. 3/10 times 5/9. When I go through and I multiply these, I'm going to use this canceling process again. And notice that I have 3 and 9, with the 3 being in the numerator, the 9 being in the denominator. So I'm going to divide both of those by 3. 3 divided by 3 gives me 1. 9 divided by 3 gives me 3. But notice I also have a 5 in the numerator and a 10 in the denominator. I can divide both of those by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. I was able to do it with both numerators and both denominators. Now I'm going to go through and multiply straight across. 1 times 1 is 1. 2 times 3 is 6. My final answer is 1/6. Had I gone through and not done that, first of all, here's the original problem. 3/10 times 5/9, I would have had 15/90, which then I would have had to figure out, well, what is that in lowest terms? And if I did divide by 15/15, I would get 1/6, but that's a lot more cumbersome to do. So we've looked at multiplying a fraction by a fraction. Let's look at multiplying a whole number with a fraction. Let's say that you were asked to multiply 5 times 3/4. This really is fairly easy. You just need to think about that 5 as a fraction. Well, anytime you have a whole number, you can always write it as a fraction by putting it over 1. So I'm going to think about 5 as 5 over 1, and then I'm going to multiply that by 3/4. When I have that, there's nothing that I can cancel. So I just have to go straight across and multiply. 5 times 3 is 15. 1 times 4 is 4. But I want to caution you. You cannot leave it as 15/4 because that is an improper fraction because the numerator is larger than the denominator. Remember in an earlier section we had talked about changing an improper fraction to a mixed number. And what we had talked about is, although there are different ways to do it, perhaps the most efficient way is just to divide 15 divided by 4. 4 goes into 15 3 times. 4 times 3 gives me 12. I subtract, I get 3. So I can form my fraction now as 3/4. So the final answer to this, you cannot leave it 15/4 because that's an improper fraction. The final answer to this problem is 3 3/4. Let's take a look at another one. 5/12 times 6. I'm going to rewrite this as 5/12 times 6 over 1. This time I notice that my 6 and my 12 have a common factor of 6. So I'm going to divide them both by 6. 6 divided by 6 gives me 1. 12 divided by 6 gives me 2. And now I'm going to multiply straight across. 5 times 1 gives me 5. 2 times 1 gives me 2. So I have 5 halves. But once again, this is an improper fraction. So I need to go through and change that. So I'm going to divide 5 by 2. 2 goes into 5 2 times. 2 times 2 gives me 4. I subtract, I get 1. So the fraction that I have is 1/2. So the final answer to this problem is 2 1/2. How about multiplying a mixed number with a mixed number? Let's say that you are given 2 2/3 multiplied by 2 1/4. In order to do this, first of all, I need to go through and change both of these mixed numbers to improper fractions. So remember, once again, back in an earlier section, we had talked about going through and doing that. If I have 2 2/3, I am going to change that to an improper fraction by, first of all, multiplying. 3 times 2 gives me 6, and then I'm going to add the 2. That's equal to 8/3. I'm going to do the same thing with the 2 1/4. I'm going to multiply. 4 times 2 gives me 8, plus 1 gives me 9, so I get 9/4. So I'm multiplying 8/3 times 9/4. Now, when I go through and multiply 8/3 times 9/4, I can do some canceling. So I see I have an 8 and a 4, and they have a common factor of 4. So I'm going to divide both of those by 4. 8 divided by 4 gives me 2. 4 divided by 4 gives me 1. I also see with the 9 and the 3, I have a common factor of 3. I'm going to divide both of those by 3. 3 divided by 3 gives me 1. 9 divided by 3 gives me 3. Now I can go straight across and I can multiply. 2 times 3 on the top gives me 6. 1 times 1 on the bottom gives me 1. I'm not going to leave it as 6 over 1 because I know that 6 over 1 is equal to 6, which is just the final answer to the problem. Let's do another similar type of problem, a mixed number times a mixed number. I have 3 1/5 times 2 3/4. The first thing I'm going to do is I'm going to go through and change both of those to improper fractions. So when I do that, 5 times 3 gives me 15. 15 plus 1 gives me 16. So I have 16 fifths times, I'm going to do the same thing with 2 3/4. 4 times 2 gives me 8. 8 plus 3 gives me 11. So I have 11 fourths. Now I'm going to go through and I'm going to multiply straight across. 16 times 11 gets to be a pretty big number, but I do notice that the 16 and the 4 have a common factor of 4, so I'm going to divide both of those by 4. 4 divided by 4 gives me 1, 16 divided by 4 gives me 4. Now I can go straight across and multiply. So 4 times 11 gives me 44, 5 times 1 gives me 5. But 44 fifths is an improper fraction. So I need to go through and I need to change that. And I'm going to do that by dividing 44 by 5. 5 goes into 44 8 times. 5 times 8 is 40. I'm going to subtract, I'm going to get 4. So the final answer to this problem is 8 4 fifths. At times, you might have to multiply by more than two numbers. And here's an example. 2/3 times 1 4 fifths times 5/8. The very first thing I'm going to do is I'm going to make sure that everything is written as fractions. So, the first fraction stays the same, 2/3. The second one is actually a mixed number right now, so I need to change that into a fraction. 5 times 1 is 5. Plus 4 is 9, so that's the same thing as 9 fifths. And then the third number is already a fraction, 5/8. So I'm going to need to multiply all three of these. Now once again, I could go through and just multiply all three numbers on the top, all three numbers on the bottom, but then I'm going to have some fairly large numbers. So I'm going to go through this canceling process. I take a look and I see that I have 2 5s, one on the top, one on the bottom, here and here. So I can divide both of those by 5. 5 goes into 5 one time, 5 goes into that 5 one time. I also notice that I have a 3 and a 9. I can divide both of those by 3. 3 goes into 3 once, 3 goes into 9 3 times. And finally, I notice that with the 2 and the 8, I have a common factor of 2. So I'm going to divide both of those by 2. 2 divided by 2 gives me 1. 8 divided by 2 gives me 4. So now when I multiply straight across, I have 1 times 3 times 1, which just gives me 3. I have 1 times 4, which just gives me 4. So my final answer is 3/4. That's a much easier way than multiplying all three of those numbers as they were originally presented for both the numerator and the denominator. The last idea we need to talk about in this section is estimating products. So let's say that you are given 3 1/8 times 5 5/6. I want to give an estimated answer to that. So much of what we do in real life is estimating. In order to do that, I'm just going to take a look at those two mixed numbers that I have, and I'm going to round them off to the nearest whole number. If I have 3 1/8, 3 1/8 is somewhere between 3 and 4, but it's closest to 3. So I'm going to change that to 3. 5 5/6 is between 5 and 6. But it's closer to 6. So I'm going to round that one off to 6. And then I'm going to multiply 3 times 6. My estimated answer for that is 18. Here's one more example. If you are given 2 7/8 times 8 1/3, 2 and 7/8 is between 2 and 3, but it's closest to 3. So I'm going to round 2 and 7/8 off to 3. 8 and 1/3 is between 8 and 9, but it's closest to 8. So I'm going to round that off to 8. Now I'm just going to multiply 3 times 8. The estimated product of those two mixed numbers is 24. I know there is a lot of information in this section. If there's anything I can do to help you as you work through it, please let me know.